ABCD is a rectangle and it is shown below. Determine the length of BD. Okay, so we're looking at this one. This length in here. In terms of x, leave your answer in third form. Okay, so that just means leave it with like a square root. Okay, so I think we have this 90-degree angle in here. So I reckon we can look at this as a triangle. I know they tell us it's a rectangle, but let's just look at this triangle. So in triangle ABD, we can use Pythagoras. And whenever you're going to use Pythagoras, it's a good idea to give the formula. So a squared plus b squared is equal to c squared. C squared is the hypotenuse. So in this case, BD is the hypotenuse because it's opposite the right angle. Okay, so we can just label this. Let's just say this is A, this is B, and then C. Okay, so we can then say 3x squared plus x squared is equal to BD squared. If we then simplify this is going to be 9x squared plus x squared is equal to BD squared. So this is 10x squared is equal to BD squared. But obviously we just want BD, so we're going to square root both sides. So it is going to be square root of 10, square root of x squared is just x. Okay, so that is our final answer. That's why they say leave it in third. So BD is square root of 10x. And then determine the size of alpha. So this angle in here. Correct to 1 decimal place. I think this is going to be a trig one. So we can use, let's just get some, clear this up a bit here. Again, in this rectangle again. This is alpha, so this is the opposite side. This is the adjacent side. Opposite and adjacent. Okay, so we can use tan there. So we can say tan of alpha is equal to, the opposite side is x, over the adjacent side is 3x. And actually we can cancel these x's here. So it's going to be tan of alpha is really just equal to a third, 1 over 3. And so we can then do and we just work that out. Okay, so we're going to have alpha is equal to 18. But they want 1 decimal place. 4 degrees. And that is our final answer there. So alpha is 18.4 degrees.